So in this section, we're going to talk about radioactive decay. There are only 118 elements on the periodic table. Because there's a limit to the number of protons that can be held inside of a nucleus before the electromagnetic force just tears that nucleus apart and forces out some type of particle. Nuclei can become unstable if they get too large, or if they have too many protons or neutrons, or if they just have some excess energy. When they become unstable, they'll undergo radioactive decay and release some type of particle in an attempt to become more stable. When a nucleus is too large, the electromagnetic force will overcome the nuclear forces and it'll force out a helium nucleus, which is 2 protons and 2 neutrons, which is also known as an alpha particle. This is entirely due to the size of the nucleus, because you have more and more things in there. Eventually, it's just too big. The strong force which holds those nucleons together is overcome by the electromagnetic force, and it just forces out an alpha particle. And so any element larger than bismuth, so larger than 83 protons, is going to have some type of alpha decay, along with other types of decay as well. You can also have this happen with smaller nuclei, just based on how many protons and neutrons they have. And if you go back and look at that chart of nuclides, you'll see that lots of isotopes alpha decay. Likewise, if a nucleus has too many neutrons, a neutron can spontaneously decay into a proton and an electron. And in this case, the electron is called a beta particle because it comes from the nucleus and is ejected out of the nucleus as an electron. And the neutron changes into a proton. So in this type of decay, the number of protons in the nucleus actually increases, and it changes the element. It becomes something else because now it has more protons. Gamma decay is whenever a nucleus has some amount of excess energy, it can emit an energetic photon, sometimes called a gamma ray. Photon is just a light particle. So think somewhat like high energy light. This just allows to settle down the nucleus a little bit as it releases some energy. Doesn't necessarily change anything about the atoms, as the other 2 types of decay do. So let's just look at how we could determine the products if we know the type of decay. So what's produced whenever uranium-232 undergoes alpha decay? Well, we're going to start off with uranium-232. And we know that we're going to end up with an alpha particle, which is just a helium nucleus. 2 protons, 4 nucleons. Now, because the number of nucleons overall can't change, then if we have 92 protons when we start and we lose 2, we're going to wind up with 90 protons remaining. If we have 232 total nucleons and we lose 4, we're going to wind up with 228 nucleons. And if you look on the periodic table an element with 90 protons is thorium. And so these are the decay products from alpha decay, an alpha particle and a thorium nucleus. Because thorium is still radioactive or unstable, it'll continue to decay until it reaches a stable product. Well, what happens if tritium, which is hydrogen with 2 neutrons, undergoes beta decay? Well, again, we can't have any extra stuff laying around.